All right, so in this video, we are going to try to go over the quiz, quiz 5, which we just completed. And I'm going to just try to do this if I can. We're going to go through this question by question, right? So let's see. Okay, we'll go over here. And this was quiz 5. Okay, so the first question, question 1, vertex, we know the vertex of a parabola, we know it's always going to be the highest or lowest point depending on whether the parabola opens up or down. So this statement is true. A linear function is increasing. That's just the same as, well, is the corresponding line increasing? And in this case, it's all about the slope. In this case, the slope is 8, which is positive. So that means the line is increasing and the function is increasing. Number 3, similarly, I'm asking for the slope of this linear function. That's just the slope of the corresponding line. And we can see it's already in y equals mx plus b form, and the slope is -6. Okay, then we have want to find a point of intersection between these two graphs, which are these two lines. We want to go and solve this equation, right? So we have 2x minus 5 equals minus 4x plus 1. And see, you set that equal to equal to each other, and we can add 4x to both sides, and we get 6x. We add 5 to both sides, we get 6. So 6x equals 6. So x is going to be equal to 1. Okay, and we can see that sure enough, we could plug 1 into either one, and we'll get -3. So that's the answer to that. Okay. Question 5, that is an inequality. We want to solve 3x plus 4 greater than or equal to x minus 6. Okay. With all the x's on one side, so subtract x from both sides, and subtract 4 from both sides. So we get 2x is greater than or equal to -10, divide by 2, and we get x is greater than or equal to -5. Okay, so this is the same thing as being from -5 to infinity. Functions that have the same rate of change over any interval. Okay, we said that is basically an alternative definition for linear functions. We know that lines have that property. You take any 2 points on a line, and take the change in y divided by the change in x. You're going to get the same number as long as these points come from the same line. So number 6, the answer is linear functions. All right, which is not a quadratic function. A quadratic function is something of the form ax squared plus bx plus c. Okay, where a is not 0. Okay, so we have to have a non-zero x squared term, and you can see we have one here. This one, if we were to multiply this out, we get x squared minus 8x plus 16. Here we have an x squared term. And here we have an x squared term, and I'm sorry, and over here, this first one, pi squared, we're squaring pi, but we are not squaring x. So that's why that's why this is actually a linear function, because it's in the form of mx plus b. So this is if it's linear, it can't be quadratic. Okay. The graph of a linear function cannot have a turning point because graphs of linear functions are lines, and lines do not have turning points. Conversely, on number 9, the graph of a quadratic function, that's a parabola, that always has a turning point because it always has a vertex. So this is true. Okay. Parabolas are symmetric, but they're not necessarily symmetric with respect to the origin or the y-axis or the x-axis. It's the axis of symmetry, right? Y equals minus b over 2a. Okay, because it's a parabola. Okay, this is the vertical line that goes through the vertex. All right, and then we use that formula to find the vertex of this parabola. Here, in this case, we can see that this is in the form of ax squared plus bx plus c, where a is 1, b is -6, and c is 2. So minus b over 2a is going to be minus 6 over 2 times 1. This is positive 6 over 2, which is 3. Okay. And if we plug 3 into this, we get 3 squared minus 6 times 3 plus 2. That's 9 minus 18 plus 2. And that is going to be -7. So the vertex is 3, -7. Okay. In this case, it's the same question, but a different type of strategy. There are two forms of a, you can write a quadratic formula or quadratic function. One is ax squared plus bx plus c. The other one is a times the quantity x minus h squared plus k. Okay. That's a quadratic, and it will be a quadratic function. And this really just comes across as we're taking the parabola y equals x squared and applying some transformations to it. So because this is y, or x minus h, we can see h is -3. And then this is -5. That's plus -5, so k is -5. So the vertex is actually going to be -3, -5. Okay. On problem 13, the axis of symmetry for this quadratic function. In this case, a is 3, b is 5, c is 1. Negative b over 2a is going to be -5 over 2 times 3, or -5/6. Okay, and then which is it? Is it x equals -5/6 or y equals -5/6? Well, remember the axis of symmetry is a vertical line, so that's given by a vertical line is given by x equals some number. Okay, so x equals -5/6. Problem 14. Where is this function increasing? Well, same one. This is a parabola that opens up. We were to we know it opens up because the coefficient of x squared is positive, and so it's going from decreasing to increasing, and it starts increasing after the x coordinate of the vertex, which we already found to be 3. Okay, this is the point 3, 3, -7. Okay, so when x is bigger than 3, this is increasing, so the answer is 3 to infinity. Question 15, what's the smallest possible value of f of x? That's really, what's the smallest value that x squared minus 4x can be? In this case, again, you want to look at the graph, and because this, once again, this graph will sort of tell you the story. you'll see that you can check that there are x-intercepts at 0 and 4, but really all you need to know is what this vertex is, which is 2. You know, if you do the minus b over 2a, minus b is -4, a is 1. So the x-coordinate is 2, and you plug 2 in there, you get 2 squared minus 4 times 2, and that will be 4 minus 8, or -4. Okay. So because this vertex is the lowest point on the curve, that's the lowest value of y on this graph, and y is represented by the function. So the smallest value of this function is -4. Okay. 16, this parabola opens down because the leading coefficient is negative. Okay. Next one, in 17, is probably the most difficult one on the whole exam. For this one, you had a quadratic function where a is 1, b is -2, and c is -2. So you have to use the quadratic formula, minus b plus or minus the square root of b squared minus 4ac over 2a. We use the quadratic formula to find the x-intercepts. So this is going to be minus 2 plus or minus the square root of -2 squared minus 4 times 1 times -2 all over 2 times 1. And this is going to be plus 2 plus or minus the square root of 4 minus -8 over 2, which is 2 plus or minus the square root of 12 over 2. Okay. So that our answer is right up here. 2 plus the square root of 12 over 2, and 2 minus the square root of 12 over 2. You could have reduced it, of course, but you didn't have to. All right. Here at question 18, we wanted to find the equation of a parabola where the vertex is 1, 3, and it passes through this point 0, 5. In this case, you have to use the second formula for the parabola again. Y equals a times ax minus h quantity squared plus k. And we want the vertex is hk, and that is 1, 3. So y is going to be a times x minus 1 quantity squared plus 3. Okay, and then what is defined, what a is, we plug in x equal the coordinates of the other point, x equals 0 and y equals 5. So 5 equals a times 0 minus 1 squared plus 3. So this means 5 is equal to a. -1 squared is 1. Okay, and from here you can see that a is equal to 2. Okay, so y is going to be 2 times x minus 1 squared plus 3. All right, question 19, you just had to draw this and just think about it a little bit. Here's our graph. Here's our axes. Okay, here's 4, 8. Now G is the graph of a line with a negative slope. So this is the graph of G. And F has a positive slope. So it will look like this. This is the 0.48. In particular, the x-coordinate is 4. And we ask, okay, well, when does when is f less than g? When is g have the upper hand? Well, the upper boundary. Well, we can see right here, this line of g is going to be above the line of f. Okay? So we can see that from here, we can see that because any y coordinate on this part of the line is greater than the y coordinate of this part of the line, we can see g is going to be greater than or equal to x as long as we're to the left of 4, which means we want x to be less than or equal to 4. And then question 20, when is if the discriminant's negative, what happens? Well, you just have to sort of go back to this quadratic formula here, and we can see if the discriminant is b squared minus 4ac, that's the number underneath the square root. If that's negative, then this expression doesn't exist, or it's not real, which means there aren't any x-intercepts. So the answer is there would be no x-intercepts. Okay. All right, so that should be, if you have any other questions, if I went over this too fast, just contact me by email. And I guess that will be that.